Alright, in this lesson we're going to be looking at quadratic inequalities. And really quadratic inequalities are just like any other kind of inequality that we've graphed before in terms of linear inequalities or absolute value inequalities. We're really just going to graph this thing. We're going to graph the equation almost as if it was an equal to sign instead of a less than or equal to, a greater than or equal to, or a less than or greater than symbol. We're going to graph it the same way we would normally graph the function. The only difference is we have to use a dotted versus a solid curve this time. Just like with linear, we would use a dotted versus a solid line based on the fact that we have an equal to condition or no equal to condition. All right. And then just like any other inequality, we're going to shade one side or the other, all right? And we're going to do that by testing a point to see what works and what doesn't work, all right? For example, if I look at this first one, what I want to do is, I want to think about this thing in terms of if this was just y equals. So if this was just y equals x squared minus 4x minus 5, I got to think, how would I graph this thing? And probably what we would do is we would find the vertex. So I would probably do the opposite of b over 2a. So that's a 4 over 2 times 1. So that's a 4 over 2, which gives me a 2. That's the x value for my vertex. I have to plug that back in to get the y value for my vertex. So I plug that 2 in, so I got 2 squared minus 4 times 2 minus 5. And I just simplify this. That's a 4 minus 8 minus 5. Which looks like it's going to give me a negative 9. And there's a couple other pieces of information here. I could use like the Y-intercept. So the Y-intercept is when I plug a 0 in for x. And when I plug a 0 in for x on this one, it gives me a negative 5 out for y. I could find the x-intercepts if I wanted, and I could do that by factoring if I plug a 0 in for x. So there's lots of different things that I could use here. I'm just going to stick with those two things. And as I go to graph this thing, so let's see, I've got 2, negative 9, which doesn't look like it's going to really fit. I'll just extend the graph a little bit. So I'll do 2, negative 9. It's going to be right around here somewhere. And then the y-intercept of negative 5. It's right here. I can reflect that point over my axis of symmetry, which I don't have drawn here, but that's okay. I can even use the fact that I have the NA value of 1, and I count over 1, up 1, over 2, up 4, which gives me my y-intercept, over 3, up 9, would give me my x-intercepts, and then over 4, up 16 if I wanted. All right, so I've got a lot of information that can help me graph this thing. And now from here, I just use a solid versus a dotted curve here, and the thing that determines that, once again, right here is our inequality. Because there's an equal to condition this time, I'm going to use a solid curve. So I'm gonna use a solid curve instead of a dotted curve. So I draw my curve. Again, it's a solid curve, and now I just have to decide if I'm going to shade inside this thing or outside this thing. And the way to do that is I test a point. So here I'm going to test the point 0, 0, and I'm going to plug that in. So when I plug in 0, 0, I get 0 is greater than or equal to. When I plug 0 into the other side, I get a negative 5. So I get the statement that says 0 is greater than or equal to negative 5, which is a true statement, which means I shade that side of the graph. Okay, so since 0, 0 worked, I shade everything where 0, 0 is. So I'm shading the inside of this thing. Okay? And here's what it looks like. And so when we graph this, again, it's really no different from anything else we've done. But now I'm just using a parabola. So I'm drawing a parabolic curve and then shading either inside or outside the curve. Okay? If I look at the next one very similar. I'm going to approach it the same way. I have to graph this thing. And again, if I want to graph a parabola, first of all, I should always identify the vertex. Now this one's in vertex form, so my vertex this time is going to be a 1, 2. And again, remember, we take the opposite of this guy and this guy just as is. That's my HK, that's my vertex for this one. And now from here, the way I'm going to graph this one, I'm just going to use my A value because I've got that A value of negative 1/2, which I'm going to take my standard shape and I'm going to tweak it just a little bit. So let me plot 1, 2 is right here. This thing's going to open down because the A value is negative. And I'm going to shrink this thing vertically. So instead of going down over 1, down 1, I go down 1/2. And again, I can reflect that and do the same thing in each direction. Instead of going over 2 down 4, I'm going to go down half that much. I'm going to go down 2. Instead of over 3 down 9, I'm going to go down 4.5. Instead of over 4 down 16, I can go down 8. Just right around here. And so I kind of get this wide parabola. And then once again, I look at this sign that's here. Because it's a greater than sign and there's no equal to condition, I'm going to use a dotted curve this time. Okay, so I kind of do the same approach that I've done with any other inequality. That is a terrible looking dotted line. Let me try that again. But when I have an equal to condition, I use a solid line or a solid curve in this case. When I have no equal to condition, I use a dotted curve. Now once again, I have to decide, am I going to shade inside this thing or am I going to shade outside this thing? Again, I just test a point, so I'm going to test the point 0, 0 again. When I plug 0, 0 into this thing, over here I get a 0. Over here I have a little bit more work in front of me, but when I plug a 0 into this thing, that is a terrible looking fraction. Let me try that again. Plug the 0 in, and I just have to simplify this a little bit. So I go ahead and simplify. That's going to give me a negative 1 squared, which is 1 times the negative 1/2 is a negative 1/2 plus 2. That looks like it's going to give me about a 1.5 here. So the statement that it gives me is that 0 is greater than a greater than a positive 1.5, which of course is ridiculous. So because that didn't work, I shade the other side of this line, or the other side of this curve. So I shade the outside. Okay. And that's it. I get my crayons out. That looks nice. I'm good at coloring. I'm doing a good job. Okay? But again, it's very similar to every kind of inequality we've ever graphed. I use a solid versus a dotted line or curve, and then I shade the appropriate side of the graph. Okay? If we look at these algebraically without drawing a graph, here's how we're going to solve quadratic inequalities. All right, we're basically going to solve the quadratic as an equation. We're going to act like there's an equal sign here, and I'm just going to solve it the way I've always solved it, either by factoring, completing the square, or my quadratic formula. Then I'm going to graph the solutions on a number line. So I'm going to plot those two solutions on a number line, or one solution depending on how many solutions I have. And then I'm just going to determine the inequality by testing x values. Basically, when I break this the number line into pieces here, I just test an x value from each piece and see which ones give me true statements, and that's the piece that I shade. Okay, so when I look at something like this guy, I want to solve this quadratic inequality. The first thing I do here is I just kind of treat this thing like an equation. I look at this as x squared minus 4x minus 5 equals 0, and I'm going to solve that, and I always check factoring first. So I build a bridge that gives me a negative 5. The two numbers are going to be a negative 5 and a positive 1. Since I have an a value of 1, I can go right to my two factors, the x minus 5 and the x plus 1. And now I set each factor equal to 0, so I do the x minus 5 equals 0. I do the x plus 1 equals 0. And I'm just going to solve each of these things. So the first one, I go ahead and add that 5 to each side. And that gives me x equals 5. The next one, I subtract the 1 from each side, and that gives me x equals 1. Sorry, x equals a negative 1. And now from here, here's what I'm going to do. I'm going to take those two solutions. Those are like my x-intercepts, and I'm just going to plot them on a number line. And so when I plot these on a number line, just to see what this thing looks like. See, I've got the negative 1 is down here somewhere, and I've got the positive 5 is up here somewhere. What this does is it breaks this into three separate pieces. I've got a piece here, a piece here, and a piece here. And all I have to do is I have to test a value from each of those pieces. So maybe I start with, you know, the piece in the middle because there's an easy value to choose here. And so I start with a piece in the middle. Maybe I'll test the point 0. So when I plug a 0 into this thing, I get a negative 5 is less than or equal to 0, which is a true statement, which means I shade this section of graph. So I shade this middle section that's in between here. And because there's an equal to condition, I know that I'm going to have solid points at each of these. So we can kind of see this thing taking shape. And if we choose another point, like let's say I chose a point from over here like a negative 2, if I plug a negative 2 into this thing just to test it and see if it works, when I plug a negative 2 in, that's going to give me a 4 plus 8, which is a 12, minus 5, which is a 7, so I get 7 is less than or equal to 0, which is ridiculous. So this point over here does not work, so I don't shade this section over here. And if I were to choose another point, something like maybe a 6 over in this section, I could test that point. And what's really neat here, and you should see this right away as you do a couple examples, but if I plug the 6 in, that gives me a 36 minus 24, which is a 12, minus 5, which is a 7, so I get 7 is less than or equal to 0. Notice I get the same thing here because parabolas are symmetrical, so if I go 1 in each of those directions, it's going to give me the same thing. And we find out that that section doesn't work either. And so we end up in a situation where when we pick one of these points, it's either going to be the inside or it's going to be the outside. It's going to be one of those. It's not going to be both. So once we find a section that works, it should narrow it down for us in terms of whether we're in the middle section or the two outer sections. And so this one ends up being the middle section here. And so to actually write our solution, when we look at this, we have to basically interpret this graph. And when I look at this graph is actually the inequality -1 is less than or equal to x less than or equal to 5. And so that's the solution that I actually come up with. It becomes a compound inequality. And when you think about it, it's because this is what's happening. The graph of this actual parabola would be this guy right here in terms of the two x-intercepts, and I'm shading everything inside the parabola instead of outside the parabola. And really this is the exact same answer, this exact same question that we had for the very first question on the first page. We're just zoomed in on the x-axis, which should feel very familiar to you because that's the same thing that happened with our absolute value functions. Okay? If we look at another example here, if I take a look at this next one, again, I'm going to say essentially that this thing equals 0 because I'm really trying to find the x-intercepts because that's what I'm doing. I'm focusing in on the x-axis as we kind of saw in the last one. But if I take a look at this guy, I just pretend for a moment that there's no inequality. I set it equal to 0 and I'm going to solve this thing for x. So here I'm going to solve using my square root property, so I'm going to subtract the 2 from each side. That's going to give me a -1/2 times the x minus 1 squared equals a -2. To undo that -1/2, I'm going to multiply each side by -2. When I do that, it's going to cancel out the -1/2. That's going to give me an x minus 1 squared equals a +4. Now I'm going to take the square root of each side. And when I do that, I'm going to be left with x minus 1 equals. Over here, because I took the square root of each side, it's got to be plus or minus 2. And now from here, I'm going to subtract that 1 from each side, add that 1 to each side. And when I do that, keep in mind what I get here is x equals a 1 plus or minus 2, which means two things. I have to do 1 minus the 2, which gives me a -1. I also have to do 1 plus the 2, which gives me a +3. And so I get my two x-intercepts or my two answers here. When I plot these on the number line, got the -1 down here somewhere, and I've got the +3 up here somewhere. Keep in mind, just like in the last one, we kind of saw that it's either going to be inside these 2 points or outside these 2 points. So really I only need to test one point in order to narrow it down. And so what I do is I choose the easiest point, x equals 0 right in here. So I plug that 0 in. When I plug a 0 in, I get 1.5 over here. And over here I still have the 0, so I get 1.5 is less than 0, which is a false statement. So instead of shading this middle section where 0 was, I shade these outer two sections instead. Okay, and then right here, because there's no equal to condition, I know that I'm going to use an open dot on each of these, and it goes forever in each of these directions. And so what I get here is I kind of get this or looking inequality, and that's how I write it. I say that x is less than a -1 or x is greater than the 3. I get a compound inequality just like I did in the last one. And again, just like in the last one, the full picture here would be a dotted parabola that opens down and crosses the x-axis at these two places. And this was the second example we had on the first page, except we're zoomed in on that x-axis again. And when we zoom in on the x-axis, it gives us this compound inequality. Again, it's the exact same thing that we experienced when we did absolute value inequalities, all right? And this is why this works the way it does, okay? I'm essentially having an entire parabola where I'm shading inside or outside, but I'm focused in on the x-axis when I'm solving for x, okay? If I take a look at the next one, let me get rid of this parabola, there we go. If I take a look at the next one, again, I'm going to approach it the same way, so I take this off to the side and say, all right, x squared plus 5x plus 6 equals 0. And I'm going to solve. And again, the first way I always check for solving is I'm going to build a bridge and see if this thing factors. So I build a bridge that's a +6. The two numbers are a 3 and a 2, a +3 and a +2. So this one's going to factor. It's going to factor into an x plus 3 and an x plus 2. And again, I set each factor equal to 0, so the x plus 3 equals 0, the x plus 2 equals 0, and now I solve each. All right, over here I'm going to subtract this 3 from each side, so I find out that x equals a -3. Over here, of course, I'm going to subtract the 2 from each side, so I find out that x equals a negative 2. And looks like my hand is dragging all over the place, so I'm making a mess over here. So now I get these two values. I think about them on a number line, and really I'm just zoomed in on the x-axis, and I'm trying to decide, am I going to shade inside or outside this parabola? I've got the negative 3, and I've got the negative 2. And I want to know, am I going to shade inside or outside? Well, think about where the easiest point to choose now is. It's over here. Okay, 0 is over here now, so I'm going to plug 0 in here, and when I plug the 0 in, I get 6 is less, a positive 6. I wrote a negative down like a crazy person. So I get a positive 6 is less than a 0, which of course is a ridiculous statement. 6 is not less than 0. So instead of shading out here, which essentially narrows it down, I can't shade outside, I'm going to shade inside. Alright, so it's either going to be shaded inside or outside. Because there's no equal to condition, I put an open dot on each of these. And so when I look at the graph that I have, I've got a compound inequality, and it's the compound inequality that says negative 3 is less than x less than a negative 2. And that's it. So it's kind of showing me, am I shading inside or outside? And then I just complete the parabola. Alright? And I write this thing as a compound inequality. Again, it's the exact same thing that we looked at when we looked at absolute value functions. Okay? If I take a look at the next one, again, I'm going to approach it the same way. I take this thing off to the side and say, all right, 2x squared plus x minus 6 equals 0. I build a bridge to see if this thing is going to factor. When I build a bridge, that gives me a negative 12. Two numbers that multiply to negative 12 but add to a positive 1 are going to be a 4 and a negative 3. And with this one, because there's a 1 out, or because there's a 2 out front instead of a 1, I can't use that shortcut. There's another shortcut we can use, but some of us don't know it, so I'm going to split up this middle term. So I'm going to rewrite this as a 2x squared plus 4x minus 3x minus 6. And I'm going to factor by grouping. Alright, that's what we do when we have a value other than 1 out front. I split up that middle term and I factor by grouping. Out of this first term, group, I can factor out the 2x, leaves me the x plus 2. Out of the second group, sorry, I'm missing my x next to the minus 3 here. Out of the second group, I can factor out a negative 3, which leaves me with an x plus 2. So my two factors are the x minus 2 and the 2x minus 3. And of course, I set each factor equal to 0, so I say that x minus 2 equals 0. I say that the 2x minus 3 equals 0. And now I just solve each of these things. Okay, and I'm sure most of us can handle solving this at this point, so I'm just going to go ahead and write down the answers. X equals 2 and x equals a positive 3/2. Alright, so once again, I plot this thing on a number line and try to figure out, am I going to shade inside or outside these values. I've got the 3/2, which is like 1.5, and I've got the 2 up here somewhere. So think about where 0 is. That's the easiest point to choose. It's down here somewhere, so I'm going to plug that 0 in. 0 is on the outside, so I want to know if I'm shading inside or outside. When I plug the 0 in, it gives me a negative 6 is greater than 0, which is ridiculous. So instead of shading outside, I shade inside this time, okay? Because 0 didn't work. There's no equal to condition. So I use these open dots, and now I can see my inequality. It's a compound inequality. It's 3/2 is less than x less than 2. Alright, so again, my compound inequality, my solution here is either going to be an and inequality or an or inequality. Again, it's the same basic concept as that absolute value function, so we follow the same basic rules. Okay, a couple special situations we want to look at. If I look at these last 4 examples, when I look at these, you should notice right away that it's the same example every time. All right, essentially, the only thing that's different here is whether I have a less than or a greater than or less than or equal to or greater than or equal to. Okay, and so there's a couple special situations that we'll run into. So the first thing I'm going to do is solve one of these, and I'm going to take it off to the side since this is going to apply to all of them. So I've got x squared minus 8x plus 16 equals 0. And I'm just going to solve this thing by factoring because that's the go-to move when you're trying to solve these things. I build a bridge. That's a 16. The two magic numbers are a negative 4 and a negative 4. So this thing is actually a perfect square trinomial. Factors into x minus 4 times x minus 4, or x minus 4 squared. And then I would set each factor equal to 0. I would do the x minus 4 equals 0. And if I was a crazy person, I'd set x minus 4 equals 0 again. But of course, that's going to give me the same thing, so why bother writing it down a second time? So here I add the 4 to each side, so I'm just going to get one solution here. I'm going to get x equals 4, okay? And so we're kind of in a unique situation where we look at this thing and say, all right, I'm going to graph this. and I'm going to do that with each of these. When you think about the graph, I've only got one solution to check, it's 4. And am I going to shade inside or outside? Well, really the question is, am I going to shade both of these pieces or just the single point? And so when you kind of think about this, if I think about it in terms of outside, if I plug in something like 0 over here, all right, if I plug in the value of 0, that gives me 16 is less than 0, which of course is ridiculous. 16 is not less than 0, so it tells me not to shade this section over here, but it also tells me not to shade this section, and here's why. Think about what the graph of this thing looks like. If I only have one x-intercept, it means that's my vertex. I've got a parabola that opens up, which means instead of shading inside, instead of shading outside, I'm shading inside of this thing. But then keep in mind also, there's an open dot here. This would actually be a dotted parabola, kind of curving upwards. That is terrible. Let me try that again. I'm ashamed of myself, and I need to do that one more time. So I kind of get this dotted parabola that just touches at this one point. And so it's almost like I have an open dot here, and I'm actually going to be shading inside this parabola. But you notice that none of that shading actually touches the x-axis. And so because I don't shade on these outside pieces, and I don't shade at the point itself, there's no shaded piece, there's no shaded region that's actually going to be touching the axis. So this is one of those examples where I'd have no solution. Okay, and another example where I'd have no solution, of course, is if I had a parabola that didn't cross the x-axis and I was shading inside the parabola. That would be an issue as well. All right, so kind of think about that in that context. If I look at the next one, if I have a greater than condition, so we're approaching this the same way. If we think about this on the number line, if I have a 4 here, again, there's no equal to condition, so I know this is an open dot. But now, greater than, if I plug the 0 in, I get a true statement, which means I do shade this section. And you think about it in terms of the parabola, I also shade this section. It's a parabola, dotted parabola, where I'm shading on the outside of this thing. And so I kind of get the same basic concept here, except this is still an inequality. And there's two ways you could express this. You could say that, well, x is less than 4, or x is greater than 4, which is almost ridiculous to say it that way. You would say x is everything except 4, and the way to say that is just say x cannot equal 4. And that's implying that x is everything else. And so I would accept either one of those answers here. All right. If you think about this guy, again, this is the same thing as the problem above it, except this time I've got an open, instead of an open dot, I have a closed dot. So here at 4, I'm going to have a closed dot. And I'm not going to shade anything else, right? Because it's just like the example above it. When I plug 0 in, I get 16 is less than or equal to 0, which is ridiculous. So I don't end up shading either of these sections. So the only point where it's shaded is 4. So my solution here is just a single point. It's x equals 4. Okay, so we kind of have these unique situations, and that's why we want to think of this in terms of the whole parabola. It makes these situations easier to see. Now I can see that it's a parabola that just touches at that one part, and it's shaded inside, so the only part of the shaded region that touches is right at that value of 4 itself. Okay, and if I apply the same thing to the last one here, again, this is just like the problem above it, except now I have that equal to condition. And so when we think about that, if I have the equal to condition, so I have the 4 here, I'm going to have a closed dot here, and just like before, I get 16 is greater than or equal to 0, which is true. I end up shading this side, and I end up shading this side. So when you think about what's shaded here, it's everything. So the answer here is actually all real numbers. Okay, so the answer is all real numbers for this one, because the whole thing is shaded, because I have a parabola that opens up. It includes that point because it's solid, but then I'm shading everything on the outside, so the entire x-axis is shaded. All right, so think of these things in terms of the entire graph sometimes. Really makes things a lot easier in terms of determining something like no solution or all real numbers, or whether or not we have a single solution or just a single value that's excluded. So watch out for those special kind of cases and think of them in a couple different contexts. Makes things a little bit easier. Okay?